Hi everyone. Today we are going to start off with our linked list series. So linked list is a very important data structure from the point of view of industry applications and also from point of view of interviews, right? And it's very easy. Once you know the concepts of linked list, you can solve any possible linked list questions. Most of the questions which get asked in interviews on this topic are mostly on easy level and medium level, right? The only challenge which students usually face in this topic is that the chances of you running into a memory issue or a time limit issue is very high. The reason being because you're handling directly the memory references, right? So that's why if you are a little bit not careful, it's possible that you can have a memory leak. Okay, so the most important advice for linked list is that just practice. The more and more practice you do for linked list topic, more and more comfortable you will be with the questions and you will make less mistakes, right? Now coming back to the patterns which this linked list topic has is basically in two types. You do not have many patterns as such in linked list. We just have two main patterns in which all the linked list questions can fall into. One is reversal of a linked list. So when you try to reverse a linked list, whatever logic you follow, you can have a lot of questions, which can be solved using that logic. And the second pattern is basically the two-pointer approach. In linked list, we usually call it as slow and fast pointer. Okay, so most of the questions can be solved, or categorized into into these two broad categories. Okay, so let's try to start off with the first question within linked list, and that is our reversal of a linked list. Okay, so the question is, given the head of a single linked list, reverse the list and return the reversed linked list. So here we have a single linked list, as you can say. Yeah, so 1, then it's 2, 3, 4 and 5. Okay, and we after you do a reversal, your linked list should look like this. If you look at the solution, here they want us to fill up a question which is called as reverse linked list, and we're supposed to return the head of the reversed list. Okay, so let's try to solve this question. So the first thing you will be doing is you have a list, right? So it's 1, 2. Let's take simple examples here, and let's say we can take here 3, and let's take 4. All right, I hope everybody knows what a single linked list is. If not, you can just check out my earlier video. All right, so in the single linked list, we have this, this is called as head. So we have been given the reference to the first node of a linked list, right? I hope everybody understands what does this mean. This is nothing but the next pointer, right? In the linked list, the list node, what we have, like one node of a linked list is nothing but an object of a class, right? In this particular question, let's say that the name of the class is list node. Can you see a public class list node, which has two properties? One is a val, that is a value, and the other one is next, which is belonging to the type of list node. The reason being because this is a reference which is pointing to another object of the type list node. Okay, so usually memory reference, if it's a reference, right, usually the type of that reference is nothing but the type to which type to the memory it is referring to. All right, so in other words, this particular arrow, as you can see here in the diagram, is nothing but your next reference, right? It is pointing to the another block which is also belonging to the class which is also of type what? List node. Okay, because each one of these are of type list node, that's why this next is basically of list node. I hope that is clear, right? So we have this value part and we have this part. All right, now some of the students do have doubts when we are trying to do linked list, and the reason is because that you have been till now been dealing with primitive data types, correct? And this concept of memory references is a little different for you, right? So if you are someone who faces issue, this next part is for you. But if you're somebody who's very comfortable with memory references, you can just skip this part and move on to the next part of the video, right? So suppose especially in Java, right, because I'll be coding the today's question in Java. So what happens is this particular memory, okay, let's say this has been stored at some memory location, let's say 2000. Okay, now this block has two parts. One part is the data part, right, because it's an object of what type? List node. And according to the list node class definition, every class, object of that class will have one part which is an integer part and another part which is a reference to another list node. Okay, let's say we have another, which we have the second node here, 2. Okay, now this is stored, let's say, at 4000. I hope you all know that when it's a single linked list, or even if it's just a simple linked list, the memory allocation is dynamic. Okay, and that's why there is no continuous allocation of memory. That means usually if in an array, what you have, if it was an array, okay, the first block or the first element of the array, let's say it was at 2000, and if it's an integer array, then the next element which is stored will be stored somewhere around at 2004, right? Because one integer takes 4 bytes, and after 4 bytes is over, immediately the next block of memory will be storing your second element in the array, because it is continuous memory allocation of data. But that is not the case of linked list. Linked list is what we use when you have dynamic allocation of memory. Okay, so this is 2000, this can be 4000 or any other memory location. All right, okay. So coming back to this, now what we want is, if you look at this linked list, after 1 we want that the next, it is pointing to the node which has a data 2. So actually, which you can see here as a point, as an arrow, actually in in real, when you look at this object in memory, this basically part is going to store the address of 4000 here, because this is what a reference nothing but it's basically stores the address to where that next object is being stored in your memory. So the next object is being stored, let's say, at 4000, so that address has been stored here. So let's give some addresses here for our understanding. Suppose this is 2000, this is 4000, this is stored somewhere at 6000, and let's say this is stored somewhere as 5000. Okay, so we can draw blocks here. We have 3 and then you have 4. Okay, so here if this is 2, then what will the in the next part of this block 2 will be stored is the address 6000, because we are pointing to the data which has, pointing to the node which has what the data 3, and that is at address 6000. So we are going to store 6000 here. After 3, actually the next node which we want after this node 3 is basically 4, which has an address of 5000. Correct. Now this is the last node of a linked list. The last node of a linked list, how do you identify it's a last node? Because there is no other node, or there is no reference to to which it is pointing to, and that is why its reference is pointing to null. Like in computer science, when we do not have any defined value, we usually call it as null, right? So this basically will have simply null, which is stored, saying that this is the last memory location. Correct. So now what we do for a pictorial representation of an arrow in memory, actually this is what the blocks look like. Correct. Now let's say, suppose you have an reference, or you have a reference like this head, which is pointing to what? Memory 2000. What does it mean is, you have a variable head which has the address stored as 2000, because what? It's a memory reference, meaning this is pointing where? To this block. So when we actually draw, when you're trying to solve questions, we don't really put those numbers in, right? It's just for you to understand. Once you understand this concept, obviously you're also not going to draw the like diagrams with blocks, addresses in it, right? You're also going to use this pictorial representation of arrows, which is very easy to understand. Okay, so this is 2000, means we can say that head is actually pointing to 2000. Correct. See here, the first data which you get is 1. If you have to go to the next block, okay, in your linked list, or you want to traverse to the next data which is present in the linked list, how do you do so? You take help of this next reference pointer, right, which we have in the node. So this 4000, nothing but you're going to now point to which memory? This memory. 6000 means you're going to point to this memory, because this is 6000, and if this is 5000, you're going to point to 5000. Right? So I hope you understand what actually is the significance of this arrows in the linked list. Okay, I hope it is clear. If you have any doubts, just comment below and I will try my best to answer those. Okay, now understanding what linked list means, right, what those pointers mean actually, right? So let's try to now come back to the question, where a question is asking us to reverse the linked list. Okay, one thing to understand here in this reversal of a linked list is, they are not asked you to make changes in the data. Like, I do not have to make this 4, make this 3, make this 2, and make this 1. No, that is not what they are asking you to do. What they are asking you to do is to modify the references, modify the memory references which we are looking at. Okay, memory references means, remember, like you can see here, let me use a different color. Let's take a red color. If you see here, 4's next is right now pointing to what? Null. So they want you to 4's next to point to 3. 3's next is pointing to what? 4. Now it needs to be pointed to 2. 2's next is right now pointing to 3, they want us to point it to 1. Once next is pointing to 2, now they want us to point it to null. Basically, whatever is your first node in the linked list is now becoming the last node of your linked list, right? If you're doing so, obviously when you're returning, now this will be your new head after you reverse a linked list. Whatever I've written in the red line is basically the linked list which I have to return as part of my output, because that is a reversal of a linked list. So when you say reversal of a linked list, what they're actually trying to tell you is you have to modify the memory references of those blocks and not the data, right? I hope that is clear. Okay, so let's try to see how we can achieve that. Let's try to draw those blocks again here. We had 1, 2, 3, 4. Okay, so I'm saying 1 is here, all right, and then we had here 2, right, then it is 3, and that is 4. Okay, and we have one reference which is pointing to the head of a linked list. Just make sure whenever you're doing any linked list questions, please never ever try to manipulate the head of the linked list. Okay, that means if you try to assign this head to some another, like if you say head equal to head dot next or something like that, what is going to happen is you are going to lose the starting point of a linked list. Okay, because please remember those are references. So always when you're trying to work with linked list questions, always take one more current as your temporary reference, a different reference which is again pointing to the first node. Okay, we'll come to this. I'll let you know if a little bit in more detail that what happens if I take head as, I do not take this current and I just directly take head. Just stay tuned, right? So let's try to solve the question. Let me write here what exactly output we are expecting, right? So the output we are expecting is the first node is, this is what we want our head now to point to. 4's next should be 3. Right, 3's next should be 2 and 2's next should be 1. 1's next should become null, right, because this is null. Okay, this is what we are interested in. Now what we are going to do is we are going to take one node at a time and we are going to modify its next pointer one by one, right? Basically reversal means you have to modify the next pointer of the least node, correct? So we are going to take one node of a list of the linked list and we are going to modify it, right? So one node, if you see here, the first node, as you can see in the output, what we want is currently the next is pointing to the block 2, but in the output we want it to be pointing to what? Null. Right, so let's try to just manipulate this block. Okay, shall we? So I have taken here current. All right, so the next I'm going to do is I'm going to write let's say this is list node, so I'm going to have one more reference here, next node, and I'm going to say current dot next. What does this mean? So let's just say this is my first step. So what does current dot next mean? Current dot next is, again, you are pointing to a reference. What is current? Current is pointing to this block. What is its next pointing to? The node which is 2, right? Which might be having an address of, let's say, 3000. Okay, so when you say linked list, list node next n equal to current dot next, what you're trying to do is whatever reference this current dot next, what is current dot next actually pointing to? Let's take some color here. Current dot next is actually pointing, let's say this is your address we took, suppose 3000. This is actually pointing to an address called 3000. You are saying you're going to take one more memory reference, next node, which is of type list node. If it is of type list node, means it can only refer to a memory which is also of type list node, correct? So it can refer actually to 3000. Why? Because this 3000 actually has a list node object, correct? So you're saying whatever this current dot next is referring to, make this next node also refer to it. Okay, I hope you get this. The reason I'm explaining so much in detail is because I've seen students struggling with this part, like they do not understand how this memory references, how this assignment of memory references actually work. Okay, all right, so this is your next node. So list node next node equal to current dot next, meaning that you are saying that whatever the current dot next is currently pointing to, make this next node also point to it. So which we have done. You will come to know shortly why I have done this step. Let's take next step. Tell me, according to our output, what we want this next, the next of this one node, of this first node should point to. It should actually point to null, correct? So can I simply say here that current dot next equal to null? Yes, why not? What this is now going to do, whatever your current dot next is, what is current dot next? Current dot next is now right now pointing to an address of 3000. You are now saying break this and now make current dot next point to whom? Make current dot next point to basically null. So I'm going to say here current dot next is pointing to null. Why? Because you have made it so. Okay. Third step I'm going to write here is going to be current equal to next node. So what I did, see, in the first two steps, in these two steps, what I have achieved after you finish these two steps, you have actually, done the modification of the node, right? Exactly. Can you see this? The first, the node which is having the data 1 in the output, what we want is its next pointer to pointer null. Did we achieve that? Yes. That means the reversal of this node is achieved. So what we need to do now, we have to go and reverse the second node also, right? The next node, we have to keep on reversing every node until we finish all the reversal so that we can get a final output. Agree? So we just finished the reversal of this node, right? Now to go to the next node, how will I now go to the next node? If I have made this next as null, how do I go to the next node? The reason now we can go to the next node is because I have a reference which is pointing to next node, which is called as next node here. So now do you understand why did we do this first step? The importance of doing this first step, like list node next node is equal to current dot next, and the first part is because before I manipulate this current dot next, I just want to make sure that I have a way of reaching the next element. Okay, so once my modification is done, I want to go to the next node, so I can simply do now current equal to next node. It means whatever now your current next node is pointing to, make that current also point to the same memory location. So now what is now your current going to point to? Current is now going to point to wherever your next node is pointing to. Understood? Yes, is it clear? I hope this is clear, right? So what we have just achieved in 3 steps is we have finished reversal of one node and now we have gone to the next node to do the reversal. Okay, now let's try to do the same thing here. Let's try to actually follow the same steps and see what happens. Here we are saying now next node equal to current dot next. What is your current dot next right now? What is your current right now pointing to? An address of 3000. You are saying current next node should now point to where? Current dot next. What is your current dot next pointing to? It's pointing to this memory, right? Might be there's some address of A2. You are saying now your next node should now point to wherever your current dot next is pointing to. So what needs to be done here? This needs to be, next node is now going to be this. Okay, obviously now why are we doing this? Why is the first step important? Because after you have achieved the reversal for this node, we have to go ahead and reverse this node. So to reach this next node after its reversal of this node, we have to have a pointer. That's why we have done so, right? Why? Because this link will now be broken when you are trying to do reversal. Correct? Yes. Now look at the output which we are looking at. This particular node which we are trying to reverse, if you look at the output, the next of this node is now pointing to whom? Pointing to 1. Currently, it is in the input, it is pointing to 3. We have to break this and make it point to where? 1. Right? Now tell me, can we do that right now? In whatever we have done so far, can I achieve, somehow say current dot next point to 1? No, I cannot do that. The reason is I don't have any pointer here. Might be some of you tell me that there is a head pointer here. Agreed. I agree with that with you, right? For this particular node, I can still, make it point by saying, current dot next equal to head, right? But what if when I move on and go to the 4th node, then it will not be possible, correct? So right now, instead of null, now what I need to do is, can I say something? Can I just make one step here? Before this, if I could write one step here, previous equal to current. And let me say this previous node initially is pointing to null, right? That means I can write here previous. What will this do? Now this is pointing to previous. What is this importance of previous node? Previous reference. Previous reference is nothing but the node which you have just finished reversal of. Like for example, when you're standing at current here, okay, this is the next node which you have to reverse after you finish the reversal, correct? And this is the previous node which you have just finished reversing, right? Why do I need reference to this? The reason you need reference to this is because when you're actually reversing your current node, this next pointer should actually point to the node which you have just finished reversal of. Correct? If you do not do this, if you do not kind of store this value, you will not be able to reverse it. Okay, right? Now, initially, when the first time when we were reversing it, if you remember, the first node's pointer actually points to null. That because there is no previous to the first node, right? So it makes sense that I give a default value of null before I start, my process. Okay, I hope this is clear. So now what I'm going to do is, let me just change the numbering here. This should be now fourth step. Okay, now let's see whether we have achieved our steps. So this was basically next node equal to current.next equal to previous. So what they are saying is current.next, which is right now where 3, this should now point to where it is saying it should now point to your previous value. What is your previous value pointing to? 1. So where should this point to? Right? Did you achieve what we wanted as per the output? Look at this. The node which has data 2, its next is pointing to 1. Did we achieve that? Yes, its next is pointing to 1. Right? So did we achieve the reversal? That means the reversal of this node has been achieved. Do you understand? So now what we have to do before we go to the next node, I just have to update my value of previous, because now for this node, what will be the previous node? This will be my previous node. That's exactly what I've done here. Now I'm saying previous should now point to current. Previous was pointing right now to 1. We are saying that now make it point to wherever the current is pointing to. Where is your current pointing to? Current is right now pointing to the node 2, and that is where it is. Next, what we do, the fourth step, current equal to next node. So what is going to happen? Current is going to point here. Right? Current is pointing here. So by this, we have finished the reversal of 2 nodes, right? So now we have to reverse what? The node number 3. Now what the first step? Next node equal to current.next. So now I'm going to do this. Current, becomes my next node. Correct? Current.next equal to previous. What is current.next pointing to? 4. It needs to point to previous. So what is your previous? Basically 2. So this is going to be your next. Can you see 3's next needs to be pointed to 2? This is what we have achieved. Now you actually update your previous. So previous becomes whatever your current is pointing to, right? And current becomes whatever your next node is pointing to, right? This is your current. All right. Now, same steps. Now, what we have done, we have finished reversal of 1, 2, and 3. Now, last reversal of the last node. Here you can see the next node is equal to current.next. What is current.next right now pointing to? Current.next is pointing to null. So, you are also going to, your current is also pointing to null. Then you are saying that current.next equal to previous. Initially, current, you see current dot, what we got is next node is equal to this. Take a second. So just a second, this was basically your next node, right? This was also your current. The first step, what? Next node is equal to current.next. This is your current.next. So your next node is going to point to null, right? So this is where your next node is going to point to. Okay. Now in the second step, current.next equal to previous. Current.next currently is pointing to null. We have to break this and we are going to say current.next is going to point to what? Previous. Previous is this part. Then becomes previous is equal to current because we have finished the reversal. So this is where your previous is going to point to. Current equal to next node. So current is now going to point wherever to null is pointing. Right? Okay. So tell me now, should I again repeat the steps? No, because we have finished the entire reversal. That means this 4 steps needs to be repeated until your current is not equal to null. Can you see that? Your current is, until your current is not equal to null, you can keep on repeating the steps. Okay. Now finally, when you have to, return the list, tell me, let me just erase this part. Okay. What I'm going to do is, see, let's just rewrite this properly. Okay, this particular thing, let's just rewrite. So what is this? 4. Okay, right now, previous is pointing to it, right? Because current and next node both are pointing to null. What is the next pointing to? It is pointing to 3, right? What is 3's next pointing to? 2. 2's next is pointing to 1 and 1's next is pointing to null. Isn't this what we wanted in the output? Yes. But only difference is right now our head is still pointing at 1. That means after the while loop, we just need to do one updation, and that is that now head should be given the value of wherever your previous pointer is pointing to, right? If you do that, this is basically becomes your head, and this is now your new linked list which has been reversed. Okay, how much of time did we take this? We are basically visiting every node once, so the amount of time you're taking is O of n, right? Did we take any extra space? No, we are just manipulating the pointers. We did not take any extra space, so it's a constant space time complexity. Okay, I hope you understood this. If this is understood, let's try to go on Leetcode and just simply code whatever we have understood, right? So you already have this list node, okay, which is a single linked list node. I'm just going to remove it because it's just in comments. So now I'm going to say the first thing is what all we need. We have to have list node previous, which is pointing to null, right? Then we need to have list node current, which is pointing to what? Head. Okay, now while your current is not equal to null, what are we going to do until it is not equal to null? The first step is we are going to create list node. Yeah, so you're going to create list node, new node equal to, we're going to give the value of current dot next. Okay, so after that is done, what is the next thing you're going to do? You're going to give current dot next needs to be given the value of previous, right? After that is done, now previous is going to be updated to current because here we have finished the reversal part. So now we are going to say previous is equal to current, current equal to your new node. Okay, you keep on doing this until this is there. Finally, you just need to return the value of previous because that is where your new the new head of the linked list is going to be, where your previous is going to be stored. Now some of you would want to do something like this, like saying that head equal to previous, and then you want to return head. That is also okay, right? It makes no difference because anyways we have to return the new head of a linked list, right? So I'm going to just say return previous because I don't want to make unnecessarily one more assignment, right? So now if I submit this, this should work fine. Yeah, so this is what it should be and it works totally fine, correct? So this is which version of our reversal or of a linked list? This is the iterative version. That means we have used a while loop to done the reversal of a linked list. Okay, did you understand this? I hope this makes sense. All right, okay. Now in the next lecture, we are going to talk about the reversal of a linked list, but we are going to talk about how can we do reversal of a linked list using recursion. It's very important that for this particular question, right, of linked list, that you know both the iterative version and also the recursive version, right? So just it's very easy if you have understood the this iterative version. Recursive version is also very easy. Okay, so I hope this helps. Bye.